In this video, I will introduce the ideas of the magnitude of a vector and the components of a vector. Let's start with the magnitude. In an earlier video, I mentioned displacement vectors and velocity vectors as examples of vector quantities. A displacement vector is a vector which represents a change in position going from the initial position to the final position. This person walked 4 miles, and this person walked 8 miles. The magnitude of this displacement vector is 4 miles. The magnitude of this displacement vector is 8 miles. So these values are the magnitudes of those two displacement vectors. Notice that the 8-mile displacement is represented with a vector which is twice as long as the 4-mile displacement. In this figure, I drew velocity vectors to represent the motion of two different objects. Here I have a velocity vector which represents the motion of a human running 10 miles per hour. Here I have a velocity vector which represents the motion of a cheetah running 30 miles per hour. Notice that the velocity vector for the cheetah is drawn 3 times as long as the velocity vector for the human. Okay. So in this example, the speeds of those objects, 10 miles per hour for the human, 30 miles per hour for the cheetah, are the magnitudes of those vectors. Okay, so again, notice that in both of these examples, there is a quantity which is represented by the size of the vector that I draw. Okay. For the displacement vector, a vector which is drawn twice as long represents twice the distance traveled. In the case of the velocity vectors, a velocity vector which is drawn 3 times as long represents an object moving with a speed which is 3 times greater. Okay? So in either case, the quantity which is represented by how big we draw the vector is called the magnitude of the vector. Okay? So the magnitude is the numerical value represented by the size of the vector. Okay. Now, I should point out, this is not a super rigorous definition mathematically. This is just something to advance our understanding a bit so that we can proceed to develop the subject. And then later on, we may get to a deeper definition of the idea of magnitude. But for now, this will move us along. Okay, so now we've talked about the magnitude of a vector a little bit. Now we're going to start developing the subject more computationally. So to do this, I'm going to introduce some Cartesian axes. So we haven't seen Cartesian axes in our discussions of vectors yet, but from now on, we'll be seeing them quite a bit. So I'm going to have an x-axis here, a y-axis here, and I'm going to draw a vector A so that it is pointing into the first quadrant with its tail at the origin. Here's my vector A. Now, the magnitude of a vector A, or a vector generally, can be represented with 2 different kinds of notation. One way of representing the magnitude of a vector notationally is to just draw that same letter except without the arrow on top. So if A with a little arrow on top represents vector A, then A without the arrow on top represents the magnitude of the vector. There is another equivalent way of representing the magnitude of the vector. And in this method, what I can do is draw the vector symbol with the arrow on top, but then put that symbol between vertical lines. This symbol here with the arrow and with the vertical lines is completely equivalent to this notation here, where I simply drop the arrow entirely. So this notation as well means the magnitude of vector A. Okay. What I generally like to do when I draw a vector is near the tip of the vector, I put the notation which indicates the vector quantity itself. That would have the arrow on top. But then along the side of the vector, I put a notation which represents just the magnitude. Right? So here I'm using just the letter A without the arrow on top to represent the magnitude. Okay, so finally we come to the components of the vector. So here's how I draw the components of the vector. To start, let's say that I go to the tip of vector A, and I'm going to draw a perpendicular to the x-axis. So that's a right angle in there. So I've started at the tip of vector A and dropped down to make a perpendicular with the x-axis. And you can see that I have formed a segment here along the x-axis. This segment is called the x-component of vector A. Similarly, I can start from the tip of vector A and drop a perpendicular to the y-axis, right? So right angle in there. This segment that I form in here is what we call the y component of vector A, denoted A sub y. Now, the components of a vector can have signs. They can be either positive or negative. In this case, when we started at the tip of A and dropped the perpendicular onto the x-axis to form the x component, we landed on the positive x-axis. So in this case, the x component of vector A is positive. Similarly, when I started at the tip of vector A and dropped the perpendicular onto the y-axis, I land onto the positive y-axis. So here, the y component of vector A is also positive. One more thing I should point out, a common error that I see students make is to indicate the component of a vector like this with that subscript, x or y, to indicate the x or y component, but with an arrow on top. This would be incorrect. Okay? The component of a vector is not itself a vector, so we do not put that little arrow thing on top. Okay? One more quick example to wrap this up. In this example, I would like to draw my Cartesian axes again. And this time I'd like to draw a vector B pointing into the second quadrant. And in this instance, I'm going to project the vector onto the axes like I did before. And in doing so, I form the x component of vector B and the y component of vector B. Now, in this case, would the x component of the vector be positive or negative? And would the y component of the vector be positive or negative? And if you like, you can pause the video here and think about that on your own. Okay, so here we can see that the x component of the vector got projected onto the negative x direction. So we would say that the x component of the vector is negative. On the other hand, we see that the vector projects onto the plus y axis. So the y component of the vector is positive. Okay, so we can see that the components of a vector can be either positive or negative, depending on whether the vector projects onto the positive axis or the negative axis. Okay, so in the next video, we're going to start learning how we can use quantitative relations to connect the magnitude of the vector to the components of the vector.